To find out if the school can send the kids on a tour of a school, it's not stated explicitly, but it should be a traversability problem, which means we need to find out if you can go along every path once and only once. In order to do this, we're going to need to look at the rank or order of each vertex, which means how many lines lead away. We'll label each one. Okay, once we've done this, we can see that there are 2 odd vertices, which means yes, we can do it. Okay, we can start at one odd and we can finish at the other. So now I have to plot my traversable path, starting at one of the odds and finishing at the other. G to B, B to H, H to G, I've started at one of the odds and finished at the other. Answer, yes. Reason, because we have 2 odd vertices. What does this mean? It means start at one odd and finish at the other, including a traversal path that you can take. Question 2. The groundskeeper is offered to add one more footpath so you can start and finish the tour at F. At the moment, F is an even vertex, so as it stands you have to start at A and finish at G, or the other way around. For it to be traversable, starting at the same place and finishing at the same place, you have to have 0 odd vertices. The only way to do this by adding one path is to add a line from A to G, thus making both of these even numbers. If there's only even vertices, you can start and finish anywhere. Question 3. IT guys are laying ultra-fast dial-up internet. They need to lay cable along the side of existing footpaths so that every point can be connected. So this is connecting all the dots in the network. First we need to lay the numbers out onto our network. So we're going to take the table and put it onto the network. Now I've added all of the weights to the arcs. The next step is to lay all of the paths out in order from shortest to longest. The shortest path we have here is D to C, which is 30. The next shortest path is either F to E, or no, C to I, then F to E, 60, G to B, also 60. Okay, I've now listed all the paths in order from shortest to longest, and I'm going to start adding them, adding a path each time so long as it doesn't create a loop, starting with the smallest. Adding E to C would create a loop, so excluded. You can see at this point all of the dots are connected in a tree, so we're finished. Adding these up, our minimum spanning tree is equal to 510 meters. At $50 meters, that's $2,550 for the cost. We followed the algorithm. Part B, we need to make a connection between G and H, which wasn't initially included. So how much extra will it cost to do this instead? So if I add on this path here, that means we no longer need this path here. So it's an extra 10 meters, which is an extra $50. Final question. Running late for English class, having been let out of the gym, was the quickest sprint from PE to English. We're trying to find the shortest path from PE to English, from G to H. To do this, I need to put my boxes in order to do Dijkstra's algorithm. G is our starting point, so its total distance will be 0. I then need to update every box with its distance from G. Going clockwise. B will be 60, H will be 90, A will be 70. The shortest of these is B, so B will be stop 2, final distance of 60. We need to work out from B. I will be 200 plus the 60 it took to get to B. $150 plus the 60 to get to B. 80 plus 60 doesn't improve on 90, so we'll leave that. And we've done all the lines leading away from B. Our next shortest option is A, so that'll be stop 3. 70 plus 100 makes 170. 70 plus 90, 160. That's all the lines leading from A complete. Our next stop will be 90, so that'll be H, and that'll be stop 4, final distance of 90. Nothing to improve on from H, so that's finished. Our next stop will be F. $160 plus 60 doesn't improve on 170, so we're finished with F. Our next stop will be E. 170 plus 70 makes 240. 170 plus 80 doesn't improve on 210. So we're finished with E. Our next stop will be C. $210 plus 30 is 240, which ties, and our next stop will be D, stop 8, and that is our destination, so our final answer is 240. There's two possible ways of getting here, but we can backtrack. 240 minus 70 is 170. 170 minus 60 is not 160, so we didn't go that way. 170 minus 100 is 70, so we came from A. 70 minus 70 is 0. So one possible answer, G to A to E to D, 240 meters. At 1.4 seconds for every 10 meters, that will be 33.6 seconds. Could also have gone this path.